Okay, we're continuing to simplify rational expressions. We did number 1 and 2. Now we're going to do number 3 and 4. As you can see, 3 is short, 4 is long. So number 3, I wouldn't necessarily even consider this a factoring problem. You really could have done this all the way back in, the second unit on the unit 2 test when you were just learning about exponent rules. So that's kind of what's going on here. There's no plus or minus sign, so there's not really any factoring in the sense that we're used to right now. You can pretty much just reduce this one. But let me show you in terms of factoring. So if we look at this one, 12x to the 10th over 48x to the 12th, you might notice the 12 and the 48 have common factors. Really, the common factor is 12. You might have noticed 4 or 6 or 8, but 12 is the greatest common factor that between those two numbers. So I'm going to write each term in terms of factors of 12 like this. So when I rewrite this, the 12, I'm just going to still write it as a 12, but the 48, I'm going to write it as 12 times 4. And now we can see that we're crossing out or we're canceling out a common factor of 12. You don't have to write it like this, but I'm trying to be consistent with still making it a factoring problem. Now with the variables, hopefully you remember the quotient rule, x to the 10th over x to the 12th, you can subtract those exponents. 10 minus 12 would be -2. X to the -2 really becomes x to the +2 in the denominator. Or you can see it as 12 minus 10 is 2, and you keep the x to the 2 in the denominator where the larger exponent was. Or here's another way to write it, factored. So I'm going to just write it as x to the 10th still in the numerator. And then in the denominator, I'm going to separate out the x to the 12th like this, x to the 10th times x squared. We're not necessarily used to writing it like this. We're used to just subtracting the exponents, but this is just another way of writing it in factored form. So notice how in the denominator, 12 times 4 in red, that is 48, x to the 10th times x squared. If you add those exponents, they do add up to 12, right? And now we can see, okay, we definitely have common factors that we can cancel. So 12 divided by 12 is equal to 1. So I'm just crossing out the 12s and writing 1s. X to the 10th divided by itself is also equal to 1. So notice once again, we've crossed out everything in the numerator, which means there's actually a 1 there. In the denominator, I have 1 times 4, which is 4, and then 1 times x squared, which is x squared. So my final answer is 1 over 4x squared. Not just 4x squared, it's 1 over 4x squared. All right, that's number 3. Here's number 4, definitely a longer one. Notice that the numerator and the denominator both have 4 terms. So for both of these, as we factor, what we can do is factor by grouping. So I'm just going to make a note of that, grouping. Okay, so I'm going to start with the numerator, factor by grouping. Notice that there's 4 terms, so we separate them into groups, x squared minus 2x, and then 4x minus 8. For the x squared minus 2x, I can write that as x times x minus 2. And then for the 4x minus 8, I can write that as +4 times x minus 2. Now be careful, I'm not done factoring here. I have to keep going and finish factoring by grouping. I don't want you to stop here and think, oh, there's 2 different factors of x minus 2, and I only cross out 1. We're not done, you're still in the middle. So if I rewrite it, the common factor here is x minus 2. And then those outside terms are x plus 4. Okay, so x minus 2, x plus 4 in the numerator. Let's do a similar process in the denominator, 2x squared plus 3x plus 8x plus 12. Now, you could combine the middle terms, and then it would turn into a trinomial kind of trial and error problem. I'm going to leave it as 4 terms because I think it's good practice to do factoring by grouping, and I think it's just as fast. So I'm still going to group the terms. This is the method we generally use when there's 4 terms. 2x squared plus 3x, the common factor is just x, and then we're left with 2x plus 3. With the second group, 8x plus 12, the common factor there is 4. So I'm writing plus 4, 2x plus 3, because I divided each term by 4. Okay, now we bring it together back in the original fraction. The common factor here is 2x plus 3. So I have 2x plus 3, and then x plus 4. Okay, so that was longer in terms of the factoring. So we factored the numerator by grouping. We also factored the denominator by grouping. X minus 2, x plus 4 in the numerator, 2x plus 3, x plus 4 in the denominator. And of course, we have a common factor. In this case, it's x plus 4. So we cross those out. And then what we're left with is x minus 2 over 2x plus 3. There you go. You can rewrite it, but that's what the answer is. So the final answer is x minus 2 over 2x plus 3. Once again, because there's only one factor in the numerator and one factor in the denominator, each of those technically does not need parentheses. But once again, I actually do like leaving the parentheses because that hopefully prevents you from crossing things out that you shouldn't. So we don't cross out the x's or the 2's or little bits and pieces. Either you cross out x minus 2 or you don't. And there's no other factors of x minus 2. So we're done with that one. There's no other factors of 2x plus 3. So we're done with that one as well. So this is our final answer. So those are two more examples of simplifying rational expressions. Obviously very different problems, but what's sort of common about all four of these so far is we're factoring the numerator if possible, we're factoring the denominator if possible, and then we're canceling out common factors.